Hello everybody, this is Mr. Visoni. This video is on chapter 3.1. In chapter 3, we're going forward with the concepts of quadratic equations and complex numbers. So let's go ahead and get started. So once again, I said chapter 3 is quadratic equations and complex numbers. And in this chapter, we're going to be solving quadratic functions. That's what chapter 3.1 is all about. So we have three goals in this section: solving quadratic equations by graphing, solving quadratic equations algebraically, and solving real-life problems with quadratic equations. So concept one, solving quadratic equations. So a quadratic equation is in one variable is an equation that can be written in standard form. So we already know standard form for quadratic looks like this: ax squared plus bx plus c. And when we're dealing with equations, that means we're setting it equal to some value. A lot of the time it's going to be 0. The one variable part just means that we're only dealing with one variable, which is going to be the case in most all situations. In this case, we're going to be dealing with x. It could be y, it could be z, but there's going to be only one variable in these equations. The root of an equation is another term for a solution of an equation. In this chapter, we'll be using graphing, square roots, and factoring to solve quadratic equations, find these solutions, which we sometimes call roots. So solutions, roots, we can also call them just the x-intercepts on a quadratic equation. All right, so let's just get going with it. So goal one, we're going to solve each equation by graphing. We're going to use a t-chart. Now, I've discussed my dislike for typically graphing. And actually, I'm going to zoom in on this. But in this case, we are going to graph to see what's going on. We're going to solve this using the concept of graphing. We'll be using a t-chart. So the first equation, I've got x squared minus x minus 6 equals 0. So I'm looking for a value for x that's going to equal 0 when I run it through the equation. In other words, I'm going to plug in some value x, and I'm going to find that I get a 0 there. So I have to figure out what that value x is going to be. That's kind of tough without graphing every single point or plugging in every single point. So I'm just going to plug in these values really quick. Let's start at -3 and work my way all the way up to 3. Now by graphing, this is not going to be super exciting, but I can plug in -3 for x, square it, subtract -3, and subtract 6. Well, -3 squared is going to be 9, minus -3, that's going to be plus plus, so that'll give me 12. And then minus 6 is going to give me 6. So I have a -3 for my x, my y is 6. So that's definitely not a value that's going to be equal to 0. I'll try out -2 next. Well, -2 squared is +4. Minus -2, that's going to be plus 2 more, that's 6. 6 minus 6 is 0. So when I plug a 2 in, I get a 0. So that's going to be a solution for my quadratic. But let's go ahead and continue plotting these points or plugging these points in very quickly. -1 squared is +1. Minus -1, that's going to bring me to +2. Minus 6, that's going to be -4. 1 plus 1 minus 6 equals -4. If I plug a 0 in, 0 is really quick. 0 squared minus 0 minus 6, well, it's just going to be -6. And I'm going to plug in 1, 2, and 3 as well. 1 squared minus 1 minus 6. That's 1 minus 1, which is 0, minus 6 is also going to give me negative 6. 2 squared minus 2 minus 6. 4 minus 2 is 2, minus 6 more is negative 4. And then finally, 3 squared minus 3 minus 6. 3 squared is 9, minus 3 gives me 6, minus 6 more gives me 0. Oh, look, I've got another solution right there. So with this information, I can start to build my graph. Or I can plot out my graph, I should say. And I could have gotten the sketch going a little bit earlier if I wanted to by using the ideas from chapter 2. I could have looked at my A value, which would have been a 1, my B value, which would be a negative 1, and my C value, which would be negative 6. And I can use those values to then graph my y-intercept, 1, 2, 3, 4, 5, 6. Got a y-intercept at negative 6. Can't draw it very well. I know my graph points up because my A value is 1. So my graph points up. My B value is negative 1. I can use that information to get my axis of symmetry. My axis of symmetry would be, in this case, it would be negative B over 2 times A. Well, my B value in this case is a negative 1, and my A value is a positive 1, which would give me negative of a negative is a positive, 1 times 2 is 2. So my axis of symmetry would have actually been on the line x equals 1/2. So it looks something like that. So I can go ahead and graph all this stuff. I'm going to go ahead and do that real quick. I will use pink to graph my points. Let's see here, negative 1, 2, 3. That's actually a little bit close. Let's space that a little bit better. 1, 2, 3. Negative 1, 2, 3. Positive 1, 2, 3. And then I have no actual, well, I've got one positive value. Let me plot that really quick. 4, 5, 6. So negative 3, 6. Negative 2, 0. Negative 1, 4. Positive 1, 6. 2, negative 4. And 3, 0. If I plot all these points, I don't actually have my vertex, but I know my vertex is somewhere down here on the axis of symmetry, which was 1/2. If I plug in the value 1/2, I would get the actual value of the vertex. Let's try drawing that one more time. And I get a graph that looks something like this. If I want to get my vertex, I can plug that really quickly into the original equation. I know 1/2 is my axis of symmetry, so it would be 1/2 squared minus 1/2 minus 6. That's 1/4 minus 1/2 minus 6, which is going to give me negative 6 and 1/4. So my vertex would be at 1/2 comma negative 6 and 1/4. Or you can turn that into an improper fraction, negative 25/4. As we can see, graphing this is slow and tedious and not fun. Well, we already kind of talked about factoring. So let's see what we can do if we factor it. I'm going to do the same equation really quickly. We'll do more factoring later on in the section, but I just wanted to talk about this. X squared minus x minus 6 equals 0. Well, if I go through my 3 steps to solve this, do I have a GCF? No GCF. Do I have a special quadratic? In this case, no, I don't. I don't have a perfect square trinomial, nor do I have a difference of squares. So I can't do anything to speed it up there. But now I can do that, what we call the X box method, right? I already know my A, B, and C. A is equal to 1, B is -1, and C is -6. Use those to set up my X. A times C in this case is going to be -6. My B value is going to be -1. So I need two values, M and N, that when multiplied give me AC, which is -6, and when I add them, gives me -1. Well, two numbers that multiply up to 6 that have a difference of 1, that's going to be 2 and 3. If I have -6 and I got to get a -1, that means the larger of the two numbers is going to be negative, so -3, and then the smaller of the two will be positive, so 2. So now I've got my M and N values. Last step, I can just build my little box here. I don't even really need to do this. It's already been factored and my A value is 1, but I could just show this really quick. X squared, -6, and then I'm going to have a -3x and a 2x. Well, if I'm factoring this, it gets pretty quick now. I'm going to have an x here, I'm going to have a 2 there, have an x there, and a -3 there. These two things are my factored values in parentheses. So I've just factored my original equation, which was x squared minus x minus 6 equals 0. That's my original equation. And in factored form, it is x minus 3 times x plus 2 equals 0. Well, that's effectively intercept form. My p-value is 3. My q-value is -2. So those are going to be the coordinates of my x-intercepts. But I can also use what's called the zero product property, which we'll talk about more in depth later. And I basically just set one of these parts equal to 0. So I create two equations. X minus 3 equals 0 or x plus 2 equals 0. Well, that would mean that my x value is positive 3, and my other x value is -2. There are my solutions. Same as my intercept form values, and same as my two values on my t-chart. What a tedious thing to do, though, but we can do it. All right, let's try this again on the right side of the right side of this paper. Again, we're solving by graphing. Again, this is going to be tedious, very tedious. I've got -2x squared minus 2 equals 4x. Well, I want to get all my quadratic on one side of the equation. So the first thing I'm going to do is move that -4x over. I create a space in the middle for the x's. So I got -2x squared minus 4x minus 2 equals 0. Now I've got a quadratic. It's in standard form. I've got my three values. I know that A is -2, B is -4, and C is also -2. I'm going to use that information to start my sketch of my graph. If I've got a C value of -2, that means 1, 2. My y-intercept is at -2. So since my A value is -2, I know the graph is going to point down. And that's all I really know at this point. I can find the axis of symmetry. I guess I'll do that really quick. My axis of symmetry is going to be -b, which is -4, negative of -4 rather, over 2 times A. Well, the negative becomes positive. I get 4 over -4, which gives me -1. So my axis of symmetry is right along the line x equals -1. I could then go and plug in my axis of symmetry to find my vertex if I want to. I can do that really quick. Let's go ahead. Actually, we'll be plugging in -1 in a second. So I'll go ahead and do that when I do my t-chart. So let's build the t-chart really quick. Let me do this. And actually, I'm going to delete this stuff from the previous one so I've got some room to work. Right? I've got x and y. Again, I've got -3, -2, -1, 0, 1, 2, and 3. I use these as my starting values again. I'm going to erase this and rewrite it a little bit clearer. So I've got -2x squared minus 4x minus 2 equals 0. So again, I'm looking for some space or some spot here on my y side of my t-chart that gives me 0 for y when I plug in an x value. So I'm just going to go through these values, starting with -3, and work my way through. Well, -3 is going to give me -2 times -3 squared minus 4 times -3 minus 2. Well, -3 squared is 9 times -2 is -18. -4 times -3 is +12. So -18 plus 12 is -6, minus 2 is -8. If I plug a -2 in, I get -2 times -2 squared minus 4 times -2 minus 2. Well, -2 squared is 4 times -2 is -8. -4 times -2 is +8, so those cancel, and then minus 2 gives me -2. I just keep on going through this. -2 times -1 squared minus 4 times -1 minus 2. This is going to give me -2 plus 4, which is +2, minus 2, which is going to give me 0. All right, there's one of my intercepts. Remember, that's trying to solve this by graphing. So I'm trying to find my x values that give me the value 0, or my x-intercepts. If I plug a 0 in, this works out really quick. -2 times 0 squared minus 4 times 0 minus 2. Well, these are going to be both zeros, and the -2 is going to give me -2, which we already had for our x-intercept, or I'm sorry, our y-intercept. If I plug 1 in, I get -2 times 1 squared minus 4 times 1 minus 2. Well, -2 times 1 gives me -2, minus 4 times +1 gives me -6. And if I subtract 2 more, I get -8. And if I continue along this, actually, I'm going to get larger and larger negative numbers. If I plug a -2 in, I'm going to get -8, minus 8 more, that's -16, minus 2, I'm going to get -18. And after that, I will get negative something very large, -32. So looks like I only have one x-intercept. So if I go to plot this back over here on the right, I'm going to plot these values. I'm going to kind of go quick on this because this is taking a lot of time. -1, 0, and -2, -2 are both on my graph. Plotted these guys. Everything else is going to just go in a downward direction. And I end up with a graph that looks something like that, with my vertex at the point -1, 0. My vertex is the same point as my x-intercept. So it looks like I've only got one solution here. Again, this has been a huge pain to do. Took a lot of time. I did all this chicken scratch stuff right here. What a mess. Well, instead, let's try factoring it again. So I got to this point, -2x squared minus 4x minus 2 equals 0. If I can draw correctly. So I can factor out a 2. In fact, I'm going to factor out a -2 out of everything. Okay, x squared, -4x divided by -2 gives me positive 2x, and -2 divided by -2 gives me positive 1. All right, now I've got something that's easy to deal with. I'm going to look at this. I took a GCF out. That was my -2. Next step would be special quadratics. Well, if I look at this, I've got x squared and I've got 1. It's a trinomial, so it might be a perfect square trinomial. X squared is a perfect square. So my a squared is equal to x squared. 1 is a perfect square. So b squared is equal to 1. That means that my a is equal to x. My b is equal to 1. The only thing I have to figure out is if that 2x is the same as 2 times a times b. Well, sure enough, 2 times a times b, 2 times x times 1 is just going to equal 2x, so that works out as well. So I've got a perfect square, and I've got a 2x in the middle. So this is a perfect square trinomial. So I can rewrite this factored equation as -2 times, I'll write it in yellow, oops, my perfect square, which is going to be x plus 1 squared equals 0. And again, I can think of this as, well, this is technically in vertex form right now, but I could also rewrite this equation here. I can rewrite it by expanding it out and make it -2 times x plus 1 times x plus 1 equals 0. This is the intercept form, which means my p-value is equal to -1, and it's the same as my q-value, which is also equal to -1, which again means I only have one solution. My solution here is x equals -1. That's where my intercept is at. All right, so that's goal number 1, solving quadratic equations by graphing. If it's not evident, I do not like graphing stuff. I like sketching stuff, but having to do these t-charts is a pain. It's so much faster to do things algebraically. If you have a sketch, it's great to understand what the picture looks like, but man, that took a lot of time. All right, so let's go more into an algebraic mode. So concept 2A, solving quadratic equations algebraically. So sometimes we can solve quadratic equations using algebraic, not expressions, algebraic operations, such as addition and subtraction, multiplication and division, and square roots. So note, when we take a square root, the best practice is to not have a square root in the denominator of any fractions that we have. In other words, if I have something like this, I take the square root, I know the top breaks down into the 5 and the bottom stays the square root of 2. We can fix that just by multiplying the original fraction by a fraction that's equivalent to 1, square root of 2 over square root of 2. The top becomes 5 times the square root of 2. The bottom becomes square root of 2 times the square root of 2. But we know that that can be rewritten as the square root of 2 times 2, which can be rewritten as the square root of 4, which is just 2. So finally, I can rewrite this as 5 times the square root of 2 over 2. That's more of a proper form, because when you think about fractions, we always like to have a whole number in the denominator. I can say 5 times the square root of 2 halves. That's fine. I can't really talk about this fraction as a fraction. I can't say 5 square root of 2ths. Doesn't really work. So we always want to have a nice whole number down in the denominator if at all possible. All right, let's go ahead and try solving these algebraic equations, or these quadratic equations, algebraically. This is going to go a lot faster. We're just going to be using the stuff that we already know how to do, inverse operations, to solve. So my first one, 4x squared minus 31 equals 49. I'm trying to solve for x. So I want to get x by itself. So I'm just going to do inverse operations as much as I can. If I add 31 to both sides of the equation, my 31s eliminate each other on the left. I'm left with 4x squared on the left, and 49 plus 31 gives me 80. All right, next step, let's get rid of that 4 that's multiplying x squared. Divide by 4 on the left side gives me just 1. 4 divided by 4 gives me 1, so I've got 1x squared, or just x squared. 80 divided by 4 gives me 20. We're almost done already. Next up, I just got to take the square root on both sides, and that will get rid of the perfect square, or the second power, I should say. So square root of x squared is just going to give me x. Square root of 20 is going to be well, 20 is not a perfect square, so let's go ahead and quickly factor that. Well, 20 breaks down into 4 times 5, 4 breaks down to 2 times 2. So 20 is just, another way to write that is 2 squared times 5. I know for every pair of values inside the square root, I can eliminate that pair. Take the square root of 2 times 2, which just gives me 2. And then the inside of my square root is still 5. So I end up with x equals 2 times the square root of 5. This is almost perfect, except remember, I'm solving for x. I thought about this graph visually, or the function or the equation visually. 4x squared minus 31 equals 49. If I put everything on the other side of the equation, I would really just have the following. What I mean by this, if I subtracted 49 instead of added 31, I would have 4x squared minus 80 equals 0. Well, this is in standard form now. The 4 means it's pointed up. The negative 80 is my y-intercept. So just a sketch of my graph would look like this. Way down here is negative 80 for my y-intercept, 0, negative 80. And my graph would be very steep because it's been multiplied by 4, so it's been stretched out. Well, notice I have to have 2 x-intercepts. Those 2 x-intercepts are going to be positive and negative 2 times the square root of 5. So my solutions are x equals 2 times the square root of 5 and x equals negative 2 times the square root of 5. And I've solved it. All right, let's go through these other ones really quickly. This one will be straightforward. 3x squared plus 9 equals 0. Again, I'm just solving for x. So I've got 3x squared equals negative 9. Let's go ahead and divide by 3 on both sides. I got x squared equals negative 3. And then I'm going to take the square root on both sides. Square root of x squared is x. The square root of negative 3 at this point in the course We cannot take a square root of a negative number. It does not exist. And if you think about the graph again, if I did a sketch of the graph of this, we've got 3x squared plus 9. Well, we know 3 for my a value, again, is going to have the graph pointed up. My y value is at positive 9. Positive 9 is like up here or something. And if my graph is pointed up, that means I've got no x-intercepts. An x-intercept does not exist because it's above the x-axis. So this answer actually makes sense. There are no x-intercepts. So x does not exist that would solve this problem. I can't plug any value in for x where I square x, because if I square any x value, it's going to give me a positive value. Positive value times 3, still positive. Positive value plus 9 will be a bigger positive number and definitely not equal to 0. So it does not exist. I will add this little note though. Well, not with arrow signs. Let's try that again. Does not exist for now. ... We'll talk about that more when we go into complex numbers in the next section. All right, this one's a little bit messy because it's got a fraction, but again, it's going to be fast. Remember, I can get rid of any fraction by multiplying by its reciprocal. We'll turn it into a 1. So I'm just going to multiply both sides of the equation by 5 halves. Doing that, I'm going to get 10 over 10. That becomes 1. Perfect. So I have x plus 3 squared equals 5 times 5 halves equals 25 halves. So x plus 3 squared equals 25 halves. Let's go ahead and take the square root on both sides. Even though this expression is in parentheses, I can still take the square root. It's just going to get rid of that square, and it's going to give me just the inside of the parentheses that's left. X plus 3 equals the square root of 25 over the square root of 2. Well, let's go ahead and rationalize this. And I almost forgot. This should be a plus or minus. Let's go ahead and rationalize the denominator here by multiplying both the top and the bottom by the square root of 2 over 2. So I'm left with plus or minus the square root of 50 over 2. I can fix square root of 50 really quickly. That's just 5 times 10, which is 5 times 2. Well, that means that the square root of 50 is 5 times 2, or 5 squared times 2. The 5s can be taken out of the square root. I get 5 radical 2. So x plus 3 is equal to plus or minus 5 times square root of 2 over 2. We're almost done. Last step, subtract 3. Subtract 3 from both sides. And actually, when we write this, I'm going to write my whole numbers first. I'm running out of room here. But my answer on the left side is going to be x. I've got a minus 3 and a plus or minus 5 times the square root of 2 over 2. There's my answer. So x is equal to negative 3, and then from that negative 3, I'm either adding 5 times the square root of 2 over 2 or subtracting 5 times the square root of 2 over 2. All right. Next concept, solving quadratics by factoring. We've already talked a lot about factoring. I just want to talk about the zero product property a little bit more. So we can solve the equation using factoring and the zero product property. It states that if we multiply 2 or more expressions and their product is 0, then at least one of the expressions must be 0. In other words, if I've got a times b equals 0, then I know that either a has to equal 0, b has to equal 0, or technically both of them could be 0. And this holds for any number of things. I could have a times b times c times d equals 0. All that means is that any one of these four could equal 0. C could equal 0. All three of the other numbers could be gigantic numbers, billions, trillions, whatever, and multiply them all together. That 1 0 screws up everything for everybody else, and it becomes 0. What's nice for us when we're solving equations is if I've got something like this, I know that x plus 3 either has to equal 0 or x minus 6 has to equal 0, and that's where my answers for x come from, where my intercepts come from. If x is equal to -3, then -3 plus 3 will give me 0 in that left parentheses. If x is equal to 6, then 6 minus 6 will give me 0 in the right parentheses. All right, so let's go ahead and try solving this by factoring. And again, this will go fast. We've done a lot of this in class. I'm going to rewrite it over here. X squared minus 4x equals 45. I'm going to first move the 45 over on both sides of the equation. So what I end up getting is x squared minus 4x minus 45 equals 0. So now it's just a matter of going through our steps. Well, do I have a GCF? No GCF here. Special quad? No, I don't have that either. So I'm going to go right to my Xbox method. And again, this is a little overkill because I have a 1 value in front of my x squared, but it'll work and it's good practice. AC is equal to 45, B is equal to -4. Because of these values, I can find an M and an N that have to multiply up to 45, -45, and add to -4. Well, if I think about things that can multiply to give me 45, the first one that comes to mind for me is 9 times 5. 9 and 5 are separated by 4. So I have an M value of -9 and an N value of +5. Well, at this point, I can basically write out my answer if I want. I could say my answer is, that's a bad color to use. Let's try something a little bit darker. I could say that my answer is, actually, let's go with purple. X minus 9 and x plus 5. I multiply those together, I get 0. That's my factored form. But I can do the box method really quickly just to finish it out, since we are still practicing this. Remember, my ax squared goes up here. My c value goes down here. And then I fill in the other two with my mx and my nx. Well, my mx is going to be this. My nx is going to be this. And then I can factor out the rest. Well, I know this is going to be an x. This is also going to be an x. This is going to be a -9, and this is going to be a +5. And there are my factors once again. X minus 9 times x plus 5 equals 0. And again, with my 0 product property, that means that if x is equal to 9 or x is equal to -5, that will be a solution to my equation. There we go. Remember, with intercept form, it's the same thing as saying my p value is equal to 9 and my q value is equal to -5. All right. So, and did I do? I think I have a secondary. Oh, these are going to be just more difficult ones. I apologize. So next concept, solving quadratics by factoring the zeros of an equation. So when we're looking at the intercept form of a function, which we've done multiple times, f of x equals a times x minus p times x minus q, we know the x-intercepts are p and q. We've talked about that a ton. Because the value of the function, the output, is 0 when x is equal to p or x is equal to q, then we know, there's a typo here, we know p and q, or we call them the zeros of the function. In other words, if I take the function at p, my output's going to be 0, or the function at q, my output's going to be 0. So in other words, the zero of a function is an x value for when the function value is 0. All right, so let's go ahead and factor another one of these. This one's going to be fast. We've done a lot of factoring already. This one's a better one for that method that we have. So I've got 2x squared minus 11x plus 12. So I'm trying to find the values where x, if I plug it in, I'm going to get a 0. Well, again, I can look at my a, b, and c values. My a value is 2. My b value is negative 11. And my c value is positive 12. Using those three values, I can set up that x box thing that we've talked about. A times c, well, a is 2, c is 12, so ac is going to be 24. And then my b value is going to go on the bottom. My b value is negative 11. So I need an m value and an n value that if I take those values and I multiply them together or add them, I'm changing colors a lot here. Let's go pink. So n times n will have to give me 24, or my AC value, and plus n will have to give me negative 11. Well, I'm just going to go down the list. For 24, I've got 1 times 24, 2 times 12. Let's write these out really quick. 1 times 24, got 2 times 12, got 3 times 8, and 4 times 6. I know they have to add up to a negative number, and I know they multiply to a positive number, so they have to be both positive or both negative to give me a negative or a positive number. And if I have to add them and they give me a negative number, then they both must be negative in this case. So I'm going to need negative 1 and negative 24, or negative 2, negative 12, negative 3, negative 8, or negative 4, negative 6. Well, to get 11, there's only one choice that works. Negative 3 and negative 8. So my m value is negative 3, and my n value is negative 8. Now I've got basically everything I need. I'm just going to set up my little box over here. We're almost done. So remember, my ax squared was 2x squared. My c value was positive 12. Positive 12. And my m value would give me negative 3x, and my n value would give me negative 8x. Now I'm just factoring. From the top left here, I only have one value I can factor out of this. It's a positive x. So in that spot here, I'm going to put a positive x. X goes into 2x squared and negative 3x. To the left here, I can get a 2 and an x out of both these values. 2x times something equals negative 8x. Well, that's going to be a negative 4. And then finally, negative 4 times something is going to be negative 12 or positive 12. Well, that's going to be a negative 3. And there are our factors, x minus 4 and 2x minus 3. So I just want to break this down again really quickly. Just the visual representation of what we're doing here. We had 2x squared minus 11x plus 12. That's where we started. The X method allows us to come up with two numbers that I can use to split up Bx. My B in this case is negative 11. I split it into two parts, and those parts were negative 3x and negative 8x. And then I had some other parts that I just brought down from the beginning. Then finally, I factored using this factoring method, and I found that my factors ended up being 2x minus 3 times x minus 4. And we can show that even a little bit more clearly. I was able to factor an x out of that first part, and I was able to factor a negative 4 out of the second part. And I ended up with something that looked like this. I've got x minus 4 on the outside. I put those guys together. That's one of my terms. And then I've got a repeat of the same term in the parentheses, 2x minus 3. That's mechanically what's happening when we convert from standard form to a factored form like so. We're basically almost done. We just have to use that zero product property to finish it out. Because remember, we're trying to find it when the values equal 0. Well, I just set each part of my equation equal to 0. And I solve for x. I get x equals positive 4. This one's a little trickier because I have to do 2 steps. And I get x equals 3/2. So my answers for this problem are x equals 4, write it in purple up here, x equals 4, and x equals 3/2. There's my solution. So this factoring method allows us to drill down to factored form. And then once we're in factored form, we just use that zero product property, knowing that one of the two parentheses has to be equal to 0, either that one or this one. We set them both equal to 0 separately. We solve them both. We get our two answers. All right. We're almost done. We got a couple more quick things. So let's go through these. And actually, you know what? I'm going to do these in class with you guys. So I'm going to go ahead and stop the video right here. This is the bulk of everything that we need to know. We'll do a couple of these in class on Friday and Monday. I hope this was informative. As always, if you have questions, feel free to let me know, and we can go over stuff in class or through email or Teams or whatever you need to do. All right, I'll see you guys soon.